Hello everyone, welcome to Ekeeda platform, and this is Ravindra Jangid here, your electrical faculty. And in this video, I'm going to talk about the commutation failure, which is related with the faults and your protection system. So we will discuss one by one what is the commutation failure, what will be the cause of this, and what are the effects of the commutation failure. So we will discuss one by one, and these are the points which are listed here. So what happens if we talk about the 6 pulse thyristors having consisting the 6 valves, that is a upper commutation portion and the lower commutation portion, or you can say the positive commutation portion and the negative commutation portion. So it will at a one time it will conduct the 2 thyristors, one from your upper and one from the lower commutation portion. But what happens sometimes due to some conditions, what happens, this condition is changed, and at a time the 3 thyristors starts conducting, that is the overlapping and the commutations failure. What happens at any time the commutation, it means one thyristor should conduct for the 60 degree. So from there should be a commutation from, let us suppose I will draw first a diagram here and then I will dictate about all the points. Okay, so let us suppose there are the connections which is like this. So this is all the thyristors which are connected, and I have discussed already these thyristors. Okay guys, so now, so these are the 6 thyristors which are connected in this fashions, and we have already discussed about these. And from here we will have a load also. Here we will have one load which is connected here, that is a load, and now it will be connected to here. So if we talk about this, then I can clearly mention that this is connected to here, this is connected to this point, and this one is connected to ultimately to your this third leg. Now here we are having the 3 voltages, okay, and which are connected as a supply, EA, EB and EC here. Okay guys, now so if we give the name of these thyristors, then we can give these are the odd numbered 1, 3 and 5 thyristors, or SCR 1, 3 and 5, and here we will have the 4, 6 and 2. This way these are going to be. So what happens at a one time? So what happens at a one time? These are going to be conducted, one from the upper and the one from the lower one. So this may be a conditions. But what happens due to some conditions? Once again, I will dictate that commutation is actually as we are having the 1 and 2 balls are conducting. Then what happens in the next portion? What will happen? This one, it will not happen. It will conduct for the 360 degree. For 60 degree will have a different thyristor conduction. So first group is 1 and 2. Then the 3 will triggered, and 3 will triggered after the conduction of 1 when it is already conducted for the 60 degree. So it will be commutated for the wall number 3. It will be commutated for the wall number 3, and here the ID current will flow. Here the ID current will flow, that is the DC current. So here the ID current will flow. But due to some conditions, this commutation from wall number 1 to wall number 3 is not happening as we are actually desiring. And due to this, the voltage is decreasing and the many phenomena can be seen there. So we will discuss one by one. So let's start from the starting of this. Now, so it is saying this point is actually defining that because of the turn of time, okay, that is the T of requirements of the thyristors. So we are having the T gamma and the T of time for the thyristors. There is a need to maintain a minimum value of the extinction angle. That extinction angle, the gamma should be less than the gamma minimum. And when the T gamma is less than the T off, then the commutation failure can be seen there. So what is the gamma? That is the extinction angle. If extinction angle is 180, that is the extinction angle we have already discussed when it will be off in the reverse bias conditions, the gamma is equal to 180 minus alpha minus mu. Alpha is your firing angle. Alpha is your firing angle, mu is your overlapping angle. This 180 is given, and this is the gamma. And we are also having the beta, that is delay, another delay angle, that is the advance angle. Okay. So now the overlap angle here, the overlap angle. Okay, so this overlap angle is actually a function of the commutation voltage and the DC current. So it is a function of the commutation voltage and the DC current. So if we are talking about the overlapping angle. Now please read this: reduction in the voltage or increase in the current. The value of the voltage will be decrease here, and there will be increment in the current, or it may be both condition, that decrement in the voltage and increment in the current. This may cause or can result in the overlapping angle and reduction of the gamma below gamma minimum. Okay, so if this is happening, that is, a voltage is decrease or the current is increase or both is happening, then this will cause the overlapping angle result in the overlapping angle. There will be introduction of the overlapping angle and will cause the reduction of the gamma below the gamma minimum. That is, the gamma will become less than the gamma minimum. When it is happening, then it will cause the commutation failure. It means the transfer of the ID current should be from the 1 to wall number 3. It is kind of let us suppose the 1 and 2 is starting conducting, and after the some time it should be kind of that the 1 should decrease and the wall from the wall number 3 it should be increased. Okay guys, but what is happening due to this? What is happening? So it is not, again it will do a reverse. Okay, reverse commutation will happen, and when the reverse commutation will happen, so it is failed to commutate from wall number 1 to wall number 3. So that is called the commutation failure, all about it. So it is written that will give rise to the commutation failure. So that will be a failure of the commutations. Now, so one thing keep in your mind, if I'm talking the wall 1, 2 and 3, so wall will be outgoing wall. It means it is about to close, it is going in the forward blocking mode. Okay, and and also the wall number 3 is kind of incoming, it is going in the turn on conditions. We have already discussed these conditions: forward blocking, forward conducting, and reverse blocking conditions in the thyristors when I was explaining related with your bridges. So where we have already discussed all about these concepts. So current in the incoming wall. So I hope you have understood the incoming and the outgoing. Incoming, it means the wall is to be conducted, and the outgoing wall, it means it is to be turned off. Now, so incoming wall, the current in the now at present time, so incoming wall will have the current 0. And if we are talking of the outgoing wall, will have left carrying the full link current. It means it is carrying the current, that is ID. It is carrying the current, that is ID, and incoming, that is a wall number 3, is about to conduct, and after it happening, or you can say that after the commutation, so I3, the wall number 3, that is I3 current, will be equal to ID current, and the current in the wall number 1, which was earlier conducting, will be off condition. So that will be, the current will be in 0. That okay. Now, so this is all about, so let us say this is the wall number 1 and the wall number 2 are conducting, and here I can say that is EA, this is EB, and this is EC. Okay, so if you talk about this, then this will be EA. Once again, this will be EA and EC. Like this is it is going to be conducted here, like this it is going to be conducted here. But after some time, after the 60-degree operations of thyristor 1, it will going to be conducted. Now we will have the EBC like this. But what happens due to the commutation failure? The current for the transfer of the current from the wall number 1 to the wall number 3 is not that is not happening in a full value. Okay, so again the wall number 1 will start to conduct and the commutation, whatever the commutation should be, it now you can say the commutation becomes failure. So it is kind of like that. It is that, let us suppose this is the reference line and the current was in the wall number 1, that is I1 current was conducting like this, and it is about to 0, and here the incoming wall, that is a wall number 3, in the wall number 3 is here and it is about to conduct and the wall number, so this is the current in the I3, and this is actually the overlapping angle, and in this overlapping angle is seen there. Clear, guys? So if we draw a wall, if we draw a waveform, so it is kind of that, it is kind of that, and let us suppose this is 0 and this is pi, this is 0 and this is pi, and let us, we have fired up to here and this is alpha, so this is a firing angle from 0 to alpha value. Now what happens, let us say this is the overlapping angle, this is actually the overlapping angle, and we are left with, so this is actually a overlapping angle, and we are only left with this, and let us suppose here the wall number 3 is fired. Okay, kind of like this. So this is all about the waveform which is given, and it should be this is the, you can say, the extinction angle from here to here, and it will due to this, and if the gamma is less than the gamma minimum, because the permissible value is decided, or the particular value is decided, if it is less than this, then the T gamma will be less than the T off, and there will be a seen as the commutation failure. So we will discuss one by one here in the next slide also. So look at these points which I have included, the important are. Now firing of the next wall, let us consider that the next wall is the wall number 3. So now earlier the wall number 1 and the wall number 2 was conducting, and now we have fired the wall number 3. So generally it should be the transfer of the current from 1 to 3 should be proper, and then wall number 3 and the wall number 2 should be conducting, and this is all about written there. Okay, so firing of the next wall, and that causes the short circuit of the bridge, as both the walls, that is the wall number 1 and the wall number 3 are conducting on the same arm and will conduct. Now if the commutation from the wall number 2, here I have taken the example the wall number 2 to wall number 4. So as I was discussing about the 1 and 3, and that I have written here the wall number 2 and the wall number 4, you can take any example from the same upper portion. So wall number 2 to wall number 4. Okay, so we are assuming that the earlier the 2 and the commutation from 2 to 4 is happening. Okay guys, now so what happens, so if it is successful, then it should be transferred properly. Then the successfully only when wall number 1 and the wall number 4 are left conducting, and this state continues until the wall number 6 is fired. Earlier the wall number 2 and the wall number 4 was operating. Now due to the firing of that, okay, not earlier the 2 and 1 was operating, and due to the firing of the 4, then the wall number 1 and the 4 are operating. So it will continue to operate, with the two walls, that is a wall number 1 and the wall number 4 till now. Now the 6 is fired, then the wall number 1 and the 6 will again continue to operate. This thing is written here. Now the firing of the wall number 5 before the wall number 6 is fired. It means if we are going to fire the wall number 5 before the firing of the wall number 6, then there will be unsuccessful of the wall number 5. There will be unsuccessful commutation, you can say, or the operation, and the wall number 5 will be in the reversed bias at the time of the firing. When we are firing the wall number 5, it will be in the reversed bias. Whenever it is having the reverse bias or reverse bias voltage will be occurred there. Now, so if the commutation from the wall number 4 to wall number 6 is successful, let us say we have transferred the current ID current from the wall number 4 to wall number 6. Now it is a successful commutation. Then the pattern returns to the normal. Then this returns to the normal, except that the bridge voltage is negative. Bridge voltage is negative at that instant where the wall 4 ceases to conduction, and it means it is not conducting now. Now what happens? The voltage, the voltage across the wall number 6 just before it starts conducting is minus EAB. Now it is in the reverse bias. The voltage across the bridge, the total, I'm talking the total voltage across the bridge when the valve 1 and the valve number 6 are conducting is plus EAB. Now, if the minus EAB is greater than 0, minus EAB is greater than 0, for the valve number 6 to successful turn on, the bridge voltage when the valve number 4 is turned off is negative. Now, due to which the commutation failure in the wall number 1 in the first instance have disappeared. So what happened? The commutation, whatever the commutation failure we have seen there in the for the wall number 1, now it is kind of disappeared here, and the bridge operation returned to the normal operation. Now it is in the normal operating condition. The bridge operation is returned to the normal operation or the normal state, we can say. This is actually called the single commutation failure. We are having the two types of commutation failure, single commutation failure and the double commutation. As double commutation is more, you can say, severe type, but we are till now we are operating in the single commutation failure. The single commutation failure, you can say, that is a self-clearing. That is a self-clearing. Okay, guys. Now we are having the double commutation failure. If we are having the double commutation failure, that is that it will have the successive commutations. That is written here, the failure of the two successive commutations in the same cycle. In the one cycle, if there are one commutation failure, then it is the single commutation failure. If there are the two successive commutations in the single cycle, then it will be the double commutation failure. It is very easy to remember now. So what happens? I can say that double commutation failure. We are having the two commutation failure. One is the single commutation, another is the double commutation. So if we talk about the double commutation failure, then is going to be more severe than the single commutation failure. So this is going to be more severe. So double commutation, it means in the one cycle there is the two successive commutation failure. So it is kind of more severe if we compare the single commutation failure. Now what are the actually causes of the commutation failure? I have taken only the two important causes, and which I have written with all the elaborations here. So let's crack one by one. If we talk about the large value of there are the two reasons, or there are the 4 to 5 commutations causes of the commutation failure. I have only taken the two that is actually the more important. So large value of the DC current. So if the ID is increases, that is the DC current, which increases the overlapping angle, that is the mu. So which will increase actually the overlapping angle, that is the mu. So I can say that if the ID increases, so mu will increase. What is the mu? That is the overlapping angle. And when the overlapping angle, we are having the relation, that is the extinction angle is equal to advance angle, that is a beta, minus overlapping angle, that is a mu. So we are having the gamma is equal to beta minus mu relation. So when we are actually increasing this mu, that is the overlapping angle, then automatically gamma is to be decreased here. And when the gamma is less than the gamma minimum, when the gamma is less than the gamma minimum, then there will be the T gamma is less than the T off. T gamma is called the T off, and that is the actually condition where we can say the failed to commutate. We will write that is failed to commutate. Now this is failed to, or you can say this condition is due to the fail to regain its forward voltage blocking capability. The thyristor is having the three modes of operation: the forward conduction, forward blocking, and the reverse blocking. So we are actually starting from the reverse blocking, the forward blocking, and the forward conduction. So what is happening? The forward voltage blocking capability. Now this gamma, T gamma, okay, this is the time for which the reverse bias across the outgoing wall. So I can say this is the time, okay, well, that is the T gamma. That should be actually the less than the T off, circuit turn off time. The time for which the reverse bias across the outgoing wall. As we are having the outgoing wall number 1, as we have discussed earlier. So that wall number 1 will have that T gamma, okay, and actually that is in the reverse bias condition. So that is all about. Ultimately the relation come into picture, that is the T gamma should be less than the T off, then there will be a failed to communicate condition will arise. Now we are talking the point number 2, that is saying low AC voltage, low AC side voltage, not the AC voltage, low AC side voltage. And why it is happening? This low voltage, or you can say that is a drop in the AC line voltage, that is actually due to the fault, and the fault may be cause of your short circuit. Generally we are considered short circuit condition. Now the AC side voltage, whatever the AC side voltage is going to be decreased here. If AC side voltage is going to be decreased here due to this fault condition, then overlapping angle is also increasing, along with that increasing. We are having that relation, that is the gamma is equal to beta minus mu. So if the mu is increasing, if the mu is increasing, then gamma will decrease. Clear, guys? So what is happening due to this? The same thing is happening, that is the gamma is less than the T of, gamma is less than the gamma minimum. There will be gamma minimum, yeah. So I'm cutting it. So that is gamma is less than gamma minimum, and that causes the T gamma, that is the T gamma is less than the T of time. So that is actually written here. Now we will see the curves here. This is actually single commutation failure. Okay guys, this is a single commutation failure. This in the commutation, due to this commutation failure, this will be in the reverse bias condition. So these are actually the waveform which are given here. This is actually drawn as per taking the 6 pulse waveform, and then we have to draw. We are having the, if the 3 walls are conducting, if the one is failed to communicate. So let us say at the starting the 1 and 2 was operating, then it is operating as then 1 to 2, then it will operate the 1 to 3, but due to this commutation failure 1, 2 and 3 are operating, and according to that you will count the voltage value, and then the curve will be drawn. So this is all about the I have taken for the wall number 2, the commutation failure for the wall number 2, and this is the commutation failure for the wall number 3. Now this is the bridge, this second is given the bridge voltage waveform for the double commutation failure. This is the double commutation failure which is written here. Now please read these points, these are also the important one. Following are the effects of the single commutation failure. Let us we are having the single commutation failure, then these are the following effects which will be seen there. If I talking about the first one, the bridge voltage, okay, remains 0. Its value will be a 0 till for the period, it is a specified the period exceeding 1/3 of the cycle. So I can say the period exceeding the 1/3 of the cycle, then the bridge voltage remains 0, during which the DC current tends to increase. So at that time, what will happen? The DC current, that is ID, is going to be increased here. Now there is no AC current for that period. that period we were talking, for that period in which the two walls in a arm are left conducting. Two walls in arm are left conducting. Now, the recovery from the commutation failure depends on the following factors. This is actually not the desirable process for our converting station, so we are going to eliminate, or we are going to just reducing these factors, or you can say that these failure conditions. So it is given the recovery, if this is happening, so how we can recover our systems, then the following factors are given. If you talk about the first one, it is saying that the response of the gamma controller at the inverter. So at the inverter side, we will use the gamma controller or the controller schemes, and that response we will take. Okay, so response of the gamma controller, and that is actually connected on the inverter side. Now, current control in the link. Okay, that is the HVDC link we are having, and that current control should be applied this. That is the CCA. From the rectifier to inverter, we have discussed in the rectifier the characteristic there. The magnitude of the AC voltage. So I can say the recovery, that is the recovery, one second, the recovery of the commutation failure, is actually depending on the point number 1, point number 2 and 3. The first point is saying the response and the current control. Second point, third point is the magnitude of the AC voltage. Now, so during the commutation failure, okay, so at the time of the commutation failure, that period is specifying when the two walls, you can take any wall numbers, the wall number 1 and the wall number 3 in a arm of the bridges are left conducting, and that AC current goes to 0, and that time the AC current is going to be 0, and this DC current is continues to flow. So it is saying during the commutation failure. So if the two walls are in the process of commutation failure, then the two walls from a single arm of the bridge. These are the three arms, 1, 2 and 3. So if the single arm is operating as a 1 and the 4 are operating, let us say, in that condition. So if these are actually the left conducting, then the AC current is going to be 0 there, and the DC current is continues to flow. This due to this commutation failure in a bridge. So bridge is affected by the commutation failure, that will lead to consequential commutation failure in the series connected bridges unless the rate of rise of current is sufficiently limited by the series connected smooth reactor. So that's why we are actually using the smooth reactor. So can lead to the subsequent communication failure. If the one commutation failure occur, then there may be chances of another commutation failure if there is a series connection bridges. It means if we are talking about the 12 pulse converter, unless the rate of rise of current is sufficient to limit the series connected smoothing reactors. So I hope you have understood all these points here. So we will move.